So after we went over where you find the pixel wrangle in Houdini, of course you guys asked, where's shading wrangle? And that is somewhat straightforward to answer. So let me demonstrate by just closing down these tabs, pinning my OBJ level here, hitting Ctrl T to open up 2 tabs. One is the output tab, I'm going to drop down a mantra node there, just leave it as it is. And the other one will be by material tab. Back to the OBJ, I'm just going to drop down a sphere, create a camera by control clicking on the camera, do the same thing for an environment light, and zoom out a bit here. Just attach a small HDR to my environment light, head over to the render view and hit render. And by default you can see that Mantra renders this sphere with a white default diffuse material. Let's stop that, just head over to our Mantra out, and I'll just switch off use all processors so that my recording won't be as laggy. For now, you don't have to do that. Regarding that material wrangle, the thing with the material context is the whole context works like the VOPs. It basically is VOPs. So any node you drop down here is a VOPs node. So there's no wrangle. There's just our dreaded snippet that I'm going to drop down here. Just flag it as an output node and drag it onto our sphere and hit render again. And this results in a very, very white sphere. So let's fix that by writing a color value to our surface. And in case you don't know what the globals are called or you can't remember, there's this handy global VOP called global variables that you can just drop down. You can hover over these ports to see what those globals are and how they're called. So CF is the surface color. Let's try writing something else into that. So capital C, F equals to, and let's set this one to be red. Like so. And in the material context, it's important to notice that you access the globals and most variables, most attributes, without the @ syntax. So CF equals to 1, 0, 0. So that should be red. And yes, we have a very red sphere now. However, all the shading is gone. So this is just a solid red sphere, and I can set this to any color I like by just altering those parameters here. However, the shading is gone, and that is because we haven't specified a BSDF or a BRDF, which is the function that defines how Mantra renders a surface. And here comes the annoying / tricky part. While it is perfectly doable to specify a BSDF or BRDF in code only, it can be a bit involved, and that shouldn't be the scope of this quick tip. So while we might go over how to define a BRDF in Vex in a future video, or a future course that's maybe geared more towards rendering, what I want to do here is I just want to right click in here and go to shading BSDFs and just drop down a PBR diffuse BSDF, flag it as an output, drag it on my sphere here. And in here I can again change my color to any liking. However, what I want to do is I want to use the color info from this node here, from this snippet. So I'll have to export and expose this variable where I store my color into. And I found it the easiest thing is to just attach a constant node to that, set to vector, wired in my snippet here. And I get this out value here. Let's call it col for color. And in here, instead of writing something to CF, let's write something to col for color. And wire this into our color input of our PBR diffuse. So now I'm getting this red color, including some shading. Let's dial it back a bit so we can see we are getting this shading from our HDR that we loaded in here. Let's just delete our globals. And while this is the most basic and most hacky shader that you could assign to this sphere or to any geometry, what I find myself doing most often in this context is just dropping down a classic shader here, which brings a whole lot of features with it, and then using that for shading. So I'm just gonna apply this to a sphere. And you can see now I'm getting features like reflection, which I can dial in this shader here directly. So instead of this boring color, let's maybe generate color using our trusty old whirly noise. So I'm gonna need a seed. Gonna need 2 floats, F1 and F2. And then I'm gonna specify my whirly noise. Let's just have a look at the help page here. So in the position, seed F1 and F2. Let's just use our current position, P, then our seed, not our Z, and then F1 and F2. And then I specify another float, call it val for value, and it should be F2 minus F1. And we're going to use that to set our color vector here. And that results in this nice Wally noise shading here. One thing to keep in mind, however, is that this P is in camera space and not in world space. So we're not actually getting the position in world space on this sphere, but in camera space. And instead, what I want to do when I need the real position of things for shading is I drop down what's called a rest position node, which is set up to return my position in the object or world space. So I'm just going to wire this in here, and instead of my P, and let's screenshot that first. So instead of my P, I will now use the rest P here. So when I switch between those, I can see that makes for quite a difference. So when I tumble my camera now, this Wally noise will stay on the sphere and not slide around in an erratic fashion. One thing which is really neat in Mantra is displacement. So what if I want to use this noise here in displacement? Well, we have to modify our classic shader for that to accept an input that drives how far the surface is offset by our displacement. So I'll right click on the classic shader, go to allow editing of contents, and then maybe stop the rendering first, and then dive into the shader here. And I want to go to this area here, where the whole displacement takes place. And what I want to do is I want to hijack this built-in noise displacement, where the shader itself has a standard noise function that can drive how far the surface will be displaced of that geometry. And what I want to output here is this displacement value that we're driving with the noise. So let's just disconnect the noise that's built in there and drop down a parameter. Let's call this one my displacement. Should be a float, and let's wire this into the value slot in here. That's all I'll be doing for now. Go up again one level, and in order to enable this shading now, my displacement here. So in order to enable this displaced shading, I'm going to go to displacement and just switch on the noise. And I disconnected this whole noise here, so you can ignore those. These parameters won't do anything now. It's only important to have this switched on, so now this output gets piped into my shader. Let's wire this into our noise and disconnect it from the surface color and hit render again. And that's not doing anything yet. That is because my displacement now would like a float input, and we're giving it a vector now. So let's just fix that by setting our constant type to float. And in here, we're getting an error message because what we're creating is a vector, which is then cast to a float. So let's fix this too. But you can already see in our preview window here, we are getting this beautiful displaced Wally noise on our sphere. So, to sum up this quick tip, yes, it is perfectly doable to use a snippet in shading. However, what you'd have to do is write your own shader, including a BSDF, which can be quite involved. So, what I suggest is using one of these standard shaders, the classic shader or the principled shader, and use a snippet to generate input values for these shaders, as for example, the surface color, or with a little hack, the displacement amount. Also, while we're here in this material context and talking about shading, lighting, and rendering, I think it might be a good idea to bring Vex 101 to an end, as this course has been focusing mainly on Vex in the geometry level. And now we're getting into terrain where we're closer to the render engine and the whole shading and lighting context. So it might make sense to start talking about shading, lighting, and rendering soon. With that being said, as always, I hope you had fun with this. I'm looking forward to see any artwork that you guys create with this technique. And until next time, it's cheers and goodbye.